Meeting is being recorded.
Okay.
There you go. Sorry about that. I forgot to start the recording. Somebody reminded me.
That's fine. Let me just read you that one piece. If you are already using our new IBM support site for software tickets, you'll see that this is exactly the same site with just a few minor nuances for opening hardware tickets. All right, let's move past. The objectives here is to explain to you what we're doing for future and support, and then obviously explore the new site. So one of the things IBM has done is we recognize that many of you were not especially happy using our green screen tool for the last 40 or so years, and so we want to improve that experience and provide greater knowledge at your fingertips. You'll notice that we are now, the new tool has Watson-based insights and acceleration. In the future, you'll be able to access this with your mobile phone, and you will also be able to go direct to the expert through this new tool. Okay, again, we're moving to a more simplified and modern approach. I should not be touching my mouse. Replacing SR with this new tool. What you're going to hear the IBMers say is Cognitive Support Platform, CSP. This is really an internal terminology, but what we've done here is we're trying to pull in everything a client may need for support into one portal, of which we're referring to as the new IBM support site. The cases are easier to open. You can see far more integrated items. So if a ticket is first opened on software and then we discover that it's truly a hardware problem, that same ticket number can be used to pass over to the hardware support team. We can also have both hardware and software working off of the same ticket. So now you're not opening up 10 different tickets to get your system repaired. All right, so key changes. What are the things you as a client need to be concerned about? Obviously, you're switching from one tool to another. That's good. If you notice over on the right-hand side, the IBM support site is a live link, so please go out to that support site. I'm not going to click it now. There are lots of videos and other training material available. In particular, what you'll notice is for the hardware side, the migration will be happening throughout 2020 based on geography. So for example, in November, we have introduced this new platform on hardware for only 20 some odd countries in Africa, okay? And we have posted the plan, which of course will change accordingly throughout the year, but we have posted the plan and schedule in terms of the other geographic regions. With the ultimate plan of 100% worldwide on hardware by the end of 2020. So if you happen to forget which tool you should be using, because for a while you may be using two of them, if you go to one tool and try to open a ticket and we realize you shouldn't have opened it there, we will automatically send you to the correct site. That will happen whether you use the old tool or the new tool. All of our call home technology works the same way. It will automatically route the problem to the correct tool and the teams to support it. And if you happen to be someone who prefers to use voice and you never open a ticket on your own, go ahead and call those same numbers that you've always been calling, and we will take care of you just as we have always done. And if you've never used voice and you're wondering what telephone number you should be using, please use this link here to get that telephone number. As I already mentioned, the rollout process is by geographic area. Sometimes I forget and say things early. So what do you need to do the transition? You really don't need to do anything. We will take your existing ID, we'll port that over to the new tool. For hardware transition, the existing PMHs or the PMRs that are open today will stay on the old tool. and you will open up new tickets in the IBM support site, and those obviously will stay on that new tool. So again, for a while, you may have to be flexible and use the two tools at the same time, but that should be for a very short amount of time. One other thing that clients really need to be aware of, and this should be somewhat obvious, is obviously when you load up files with data for us to use for our analysis, whether it's hardware or software, historically you have used a PMH number or PMR number that is in this format, or potentially you use RCMS depending on where you are in the world, which is this format. And with a new tool, it will always precede by TS and then have 9 digits. And so please pay attention when you're uploading your files to follow the correct naming convention depending on which tool you are using. Okay, so how do you get there? So using the old tool, you would have used this link. Today you use this link on the new one. Again, you may have gone to service request, and in the new tool, it's over here. And these are all live links. If for some reason you have never obtained, never registered with IBM, this link will also bring you through that process. My guess is those of you on the call already know that. And again, we've repeated the column number on this slide. Not going to spend time on these items, but if you're interested, there are a lot of other new programs that have been opened. These are active links. So I will just talk about this one down here, the Engage, Earn Points, and Get Rewards from IBM VIP Rewards. This is a program where we are actively looking for your feedback so that we can improve support. You can also participate in learning challenges, so that helps you out. And when you do these activities, we will give you some points, and with those points you can earn different gifts. Please be aware that some of these rewards are not eligible in certain countries or regions, and that's because of your respective countries will not permit us to have this kind of program in terms of points. But you can participate anyway if you're interested to provide us feedback and get additional learning activities. All right, let's get to the tools. I'm going to fly through these slides. You can always come back to them later, okay, because I'm going to do a live demonstration for you. So the main screen on the new support site, you can do some searching. Excuse me. You are going to Fix Central to go get your code fixes. You're going to open your support case. You have a way to engage. You set up for yourself how you want to be notified with cases. For example, you can receive an email when you open a case, and whenever IBM submit some information against the case, or you can maybe never get an email because you don't want to deal with more emails. And there's instructions on an IBM support guide. Also on this page, you see we've called out, if you need support with the tool itself, not with your product, but with this tool itself, here's where you can do that. You also notice we have online chat. On this screen, and I will reiterate this, on this screen only, this chat with support will bring you into Watson. Watson will try to address your questions and direct you accordingly. And in the minimum, Watson will ask you to just open up a case because Watson doesn't know the answer. Now, in that search area, so now I'm talking about up here, how can we help you? Right? You can enter your text just like you would on Google. And what we are doing is IBM is not searching the worldwide net. We are only searching our own technical content. That includes such topics as Tech Notes, Knowledge Center, and our forums and other resources. Right? And obviously it pulls up information just like you have on the web, and you can sort by relevance. Okay, so the other item that I'm not going to be able to demonstrate for you, however, is managing the accounts and the contacts. And you'll see here that there is again, a live link that brings you to the education. what this is saying is that it's a lot easier for those of you who are administrators to add people, remove people, check who has what level of authorization, etc. Okay. Yes, I work for IBM Z, so all these charts are Z. I will be showing Power examples on when I do the demo. And so if you went into the product page for some information and you want to search for Z14, all of the Z screens are set up in this fashion. We give you a quick little blurb about the product. We ask what is it that you want to do, and we have some key resources. You can also use the chat here for Watson. Okay, opening a case. This is, again, I'm not going to even talk about these slides. I just want to show you so that I can talk to them as we go live. I have highlighted all of the screen sections with clues as to what you want to be taking care of. And there are multiple slides with this kind of information. And my point of showing you this is all of these slides, if you forget what I say or you just don't want to listen to me, if you go to these slides, it gives you a little bit of a clue of what should be done. And I'm going to leave it here because, yes, I'm going to leave it here because this was not working properly earlier today. So I am going to go to the tool, oops. I'm going to go to the tool now. So I'm in an integration, so a test version of what you have live. Frankly, the only major difference is it may not work as quickly as what you have, and sometimes certain sections aren't working at all. And when you sign in, you will not have this ugly yellow banner telling you that you're in the integration environment. Obviously, you wouldn't be testing for us. So again, I mentioned this is where you could search the support line. This is right here at the top of the screen. I got here by going to IBM support. If I want to open a case, I just click this. I can also click up here if I'd like. Down here is where you get help with this tool and chat with support. I was asked to concentrate on opening a case. I am not going to provide real good typing here. I'm just, because you're going to hear my typing and that's got to be rather annoying. So we are doing a demo for the AIX VUG. Depending on what portion of IBM you work with, you'll need to change this. Here, it's IBM as the manufacturer. What product is it? So as you see, because I've been playing with lots of different products, I just clicked and it pulls up the most recent things that I have been playing with. In this case, we're going to use a Power 7. You notice that I used the machine type number. You do not have to use a machine type number. You can call it Power 7. You can put in any of these entries that you see here, which is a variety of machine type models. You will absolutely have to, that's not good. Okay, you will have to select the country. Good. And in this case, we're going to show South Africa itself, so I'm just typing S. And this, again, is the way lots of things in the web work. I select South Africa. I need the serial number. And so the system found that one. They said, oh, yeah, we know that one. So you click that serial number. Service type, you're going to be calling or requesting a break fix. Okay. Normally, I would have to add the address where the machine is, but because I wanted to save a little time in this demonstration, I had it selected because this is an address I've used frequently. So once you start using addresses, the same address over and over again, it'll start populating just like you see here. Otherwise, you click Add, and you type away. Okay. You can edit your contact information. You want to select your severity. We're going to play with the Sev 1. And you enter your account number. Now, come on. All right, what I was going to show you is the authorization I have has multiple different companies that I can play with. And if your company has more than one account code with us, when you click on this field, you should be able to select the appropriate one for the machine type model that you are working on for the ticket. As you can see right now, it's not letting me do that. Again, I am in a test environment, so please understand it absolutely is working properly in production. Which operating system is part of this machine? It's an AIX. And here, I'm not going to be, again, thorough. We're just saying description. Now, if you notice, as soon as I started typing, this turned to red. It'll turn to a yellow and green eventually as you put in enough information. Okay. On the right-hand side, steps to reproduce. So it says, okay, these are little hints, right? I don't know. Okay, so now I got it yellow, and I'm sure you understand by now that once you put in sufficient information, this will turn green. I do want to emphasize this is meant to be a suggestion. If you simply type help us, we will contact you. Obviously, we prefer the more information you give us, the more likely we're able to help you even quicker, and I'm sure you all understand that. But again, if you don't go all the way to green, we'll still take the case. From here, you can upload files. Again, in my test environment, this is not working, but what this will do is bring you to the links that are associated with your particular product so that you can upload whatever base data you may have. Again, because I have been opening cases for quite a while now, I have certain team members that are already here automatically because I have picked them enough. So this is Watson Artificial Intelligence, recognizing that I keep picking these same people. If I don't want Grazi, I can just remove her. And if I go, oops, I was supposed to keep her, I can just come back and add her, or I can add Mr. John Demo instead. And what's going to happen is, depending on how John has his notifications set up, he will, if he has set his notifications up to get emails when a case is opened, that will happen for him. Now we're going to submit the case. In production, this is very fast, or it has been at least.
So while we're waiting, Anne-Marie, how about if I ask you a question?
Sure.
Somebody asked about Blue Diamond support, and I know I saw something about that. I want to talk about how, if that's changing or how that's changing.
Yeah, so Blue Diamond support is not changing at all. If you are a Blue Diamond client, you will still submit your files to Blue Diamond. Your account should be set up to recognize that you are already Blue Diamond, and it will present to you the link that's appropriate to apply those files to the Blue Diamond area.
Great, thanks.
Okay, so again, this is the title I typed in. The case number is here. As I said, it always starts with a TS. The description we have is right below that. If you would like, you can add more info immediately. Geez, I forgot to say something. You can immediately post that. Now that's processing. On the right-hand side, you can double-check some of the information you've supplied. You cannot change your product or machine serial number, so please be careful. Anything with a pencil you can change. Again, if you added, if you only added one file earlier and now you've got the second one has come in, you can go ahead and upload it right now. Client reference number. I'm going to add one here just for an example. After a while, there are going to be, a lot of cases in your records here, and you're going to want to be able to find a way to find certain of those quickly. So I would suggest you think about a good client reference convention so you can find the ones you're looking for. If I want to add or remove team members, I can also do that right now. Okay, so if you recall, we added a comment up here, and it's now processed, so it shows up here. The way these are set up by default is the first entry is at the bottom, and then the most recent is on top. If you don't like to read things that way, you can click this up, down, and now it is reversed. So old to new, or new to old. Let me save this. Okay, so now I want to go look at all of my cases. Now, again, you will not be able to see all of the things I have in front of us here. You see that John demo has opened some, Anne-Marie's opened some. So this would be what you would see for your team's cases. It would be something similar.
You see closed cases as well?
Yes.
Okay.
Yes. Well, because you won't right now because I have it set to just my open ones.
Right, but a customer could look at all their closed cases, their history and stuff like that, right?
Exactly, just by selecting a different filter.
Yeah, okay.
Okay. Your status of the case, awaiting your feedback, is IBM would like some information from our client. New case, IBM is working. Now, if you recall, I used that reference, and you'll see why. So you'll see that right now there's 29 cases that you may have to muddle through. But if you just sort on your reference, now there's just 6 of them. Much more manageable. So here's the one that we just created, and you'll see the reference pulled up here. And we've been working on it for 0 days. Okay. The next thing here I want to go to is, give me 1 second, 5135. Okay, I want to show you, hopefully show you something that was not working this morning. Oh, good, it's working now. Okay, so you first open up the case, IBM takes a look at it. As we're processing, we realize, oh, I need to send out a technician. So at this point, this particular case has advanced to where the IBM support person has opened up a work order, and the work order is used for us to give instructions to our technicians as to what needs to be done. You will not see those instructions because most of the time those are, IBM private instructions. However, trust me, they have the instructions in there. What you're also going to see is that in this case we know we need a technician. We have not yet assigned a technician. Okay, let me just check one other to see if I'm lucky, to see if I can go back to the cases, to get back to cases. And my other case, 688. All right. Okay, so now this is another order. Again, a work order has been established. We've assigned a technician. Okay, what you should see directly below this area is still not coming up, but we have not only assigned the technician, but we have also scheduled him. And so let me flip back to the PowerPoint. Oops. So where it has, where I'm showing you where pending technician, et cetera, it will show assigned. And you should also see below that window in your local time the actual appointment time, so when you should expect a technician to arrive. All right, so you don't need to call us. You can come to your case and take a look at that. Okay, so this is really the end of the demonstration. That, believe it or not, shows you pretty much all the tools you need to get started and to manage your cases. Are there any other questions that came across, Joseph?
Yeah, there's maybe just a couple here. One is there anything changing for partner world support via email?
No, that will work the same way.
Okay, and one asked if they can generate and export historical case data from the My Support.
Yes. So from here, I'm forgetting which one. Download, sorry. So this little download button with a little arrow, that will allow you to download. And it creates, as you see down here, it created a CSV or an Excel spreadsheet. Now, I don't want to open that up because for me, that has 6,000 entries in it. So it'll take a while.
Okay, and then there was the filter on here, various that just showed you were using to show different things, like what's all open. Yeah, okay. So somebody was having an issue of what they could see. Right.
Again, what the problem is because I have access to so many accounts, this is large. So you can also adjust this filter. Right. Again, these are other clients we have that I have access to in the test environment. Obviously, your filters will be smaller, but it's still the same topics. You can also sort by product. And you can move, I didn't think of this, you can move these lines around normally.
Oh, the columns?
The columns, yes, I'm sorry.
Yeah.
Apparently not.
So,
but.
Okay. No changes to call home or how the service agent is making calls, right? That's not really.
Correct. All of that is done the same way.
Right, okay.
Now, when I say the same way, one thing that you will see happening little by little is we will be communicating you more and more electronically versus calling you.
Uh-huh.
Okay, but that's going to be a slow transition. A lot of our support people are very used to calling you, so they're going to be doing that. And you're used to that, but we're also going to try to get everyone a little more used to, for the less important items, to go check the case for an update. Again, that's why you would set up your profile to receive an email, so you know we've done an update for you.
Okay. Can business partners look at or manage customer cases?
So, yes, they can, but only if the client allows the access to their account. And so you would have to have the business partner register for an ID associated with your account, and then they can come in and see everything that we've just looked at, including the opening cases.
All right. And the technician name, phone number stuff, that's all in where you said you could see the technician. Is there a way to contact them?
So the only way you can contact them is through the case.
So you have to put something in the case, and then they would get it out of that. So like access information you'd put in the case then?
Right. You could ask the technician if he wants, if he can call you. You can also ask him for his telephone number, and it would be up to him whether or not to provide that. We do that on a worldwide basis, even though that's a government requirement in some countries.
Okay. All right. So I think, so for specifics on so somebody's asking how specifics on how a business partner can get access. So I don't know if we have time to go through all of that, or if we want to just have them send in a note, or how much time that's going to take to cover.
Yeah, so they just need to go through the registration process. Where do I have that? One of these slides had a link for you where I said if you haven't registered yourself, registration information right here.
Okay, good, super. Thank you. Okay, and this is for all tickets, right? Hardware, software?
Yes, everything. Yep.
Yep, everything's okay. Good. Well, I think that's it for the examples. I think so. Anne Marie, thank you very much. This is, I think, really just good stuff for all the customers to know, and I appreciate you getting on our call here today and going.
You're absolutely welcome. And again, Joseph, if you do get questions, just forward them over to me, and I'll get them addressed.
Absolutely. And just remember, everybody, the presentation that Anne Marie went through here, it's out on the wiki. It's on the news site. That's the link that I put up there. So that should be there and working, and you can get that off. And I'll try and make sure that link stays active. So With that, thanks again, Anne-Marie, and we'll move on to our second topic.
All right, thank you. I'll use a drop now.
Okay.
Okay. All right.
So Nigel hardly needs any introduction. He's been with us several times before. World-renowned known Mr. NMon. So we're not actually talking about, at least not specifically NMon today, but Nigel's got a whole list of interesting things he's going to go through. And I looked through his presentation earlier before I was posting it, and some cool stuff in there. So with that, Nigel, I'll turn it over to you, and we'll get started.
Okay.
Let's see. Do I need to make you the presenter, or that is maybe I need to do that? Let's see.
Yeah, I'm grayed out.
Intro. Yeah. Okay. Sorry. There you go.
Okay, you can see me?
We can see your slides. There you go.
Okay, great. Okay, I've got a, I think it's the video captures right in the middle of it. Okay, right, so let's get started. So it's what's new for me. This is the things that I find interesting about what's happening in late 2019, and then should be the focus of some activity in 2020. I don't know what you all feel like. 2020 just feels like a nice year, doesn't it? It's an easy sort of off the tongue sort of year, 2020. I'm sure there's some science fiction movies that said something terrible is going to happen in 2020.
Yeah.
So I'm Nigel Griffiths, and this year I was joined the technical consultancy group, and I'm now to call myself a technical staff member. So I proudly put that in my slides, and I showed that to my wife, and she said, "You've been one of those for 30 years. What are you getting excited about?" But I'm allowed to officially, with uppercase letters, say that I'm a technical staff member now. And down here at the bottom here, we got how to contact me. We'll talk later about the AI Expert blog. It's been moved at IBM, and yeah, it's been moved, but we'll get to that much later on. So let's get started. And my button click, it does work. So let's talk about Red Books. I noticed some of these are going to be really quick, right? That all of the Red Books for all of the Power servers have been updated in the last 10 days. So if you wanted to get a quick, clean sweep of all the updates for the end of the year, then now's the time to do it. And those links will be active when you download the presentation, so you can get hold of them fairly quickly. There's also a new one. It's in draft at the moment. There's a person called Armin Raal, who's we used to call him Mr. AIX for Germany, and he still has a lot of interest in AIX, but they're writing a new Red Book about the enhancements and the modernization features. And I've been involved with putting in a couple of pages on nmon. It says down in the bottom right, it used to just have the nominal frequency, but now we have variable frequencies. And so if you looked at the nmon CPU frequency, it was a lot lower than you were expecting. But if you upgrade your AIX to 7.2 TL4, then those actually start working again. And we've also introduced a chapter on Xive, or XIVE, and I've got a half a dozen slides on that later on, so we'll just move on. So here's Miss AIX, Petra, works in Germany, and she knows that I call her that. And she's an awful lot better looking than me, so I'm being told. But anyway, let's move on. I've stolen a couple of her slides, so these are the standard sort of things that a lot of you want to see on a regular basis. Now, AIX 6.1 at the bottom is coming to a close. If you look at the top right, this goes up to year 3000. Just to make sure that some people read the last number is 2028 and assume we're just closing the AIX down at that point, because that's the highest number on the chart. So year 3000, even if there's a medical miracle, I'm not going to live that long, so that's got me covered for the rest of my life. Okay, and it goes in, AIX 6.1 goes into sort of a bit of a grey area right about now, EOL. End of life, I think that means, but I've got the actual details on the next chart. So AIX 5.3 is not supported at all. If you're running that, well, good luck. Don't phone us. Although I was thinking of personally adding support. So you could buy a support contract from me, and then if you've got any problems, you could phone me up, and I'll say, Oh yes, that's terrible. It's terrible. Yeah, something's got to be done about that. And then when I put the phone up, I won't do anything at all. That's giving you some support, isn't it? Moral support. Right, now AX61 came out in 2007. The regular support for the operating system finished in 2017, so is that 2 or 3 years ago? Depends on how you look at it. And from then on, you were into extended support, so you have to pay an extra fee on top, or pricey because we don't like supporting the really old stuff. That will get you through to April next year. If you're on fairly new hardware, the Power 7, 7 Plus, or 8, then you can carry on paying the extended support for a bit longer. On Power 7, then it's 4 months longer. Power 7 Plus, that's December 2021. That's 16 months on top of the regular extended, which is on top of the regular support. And if you're on Power 8, that goes out to 2022, 20 months longer. And at that point, I put little my arrows in here. AX7 1 came out in 2012. At that point, you've had 12 years to upgrade to AX7. I mean, we've been dragging this on and on with AX7.5, and we're going to get in the same position with AX7.1. I think we should put the support prices on a sort of doubler every year over the end of the support. We just double the price until everybody goes away. Just gets people's minds focused on it's cheaper to move than just pay the money and stay where you are. And this sort of problem in here, I mean, from 5.3 to 6.1 was a big jump. All sorts of technology came in with that jump into virtualization, for example. The way we do computers completely changed with that jump. 6.1 to 7.1, it's not a very big jump, to be honest, and 7.1 to 7.2, it's an even smaller jump. But because that prime number changes, people feel they don't want to do it in case something goes wrong, even though it's not much of a jump. And this is why we're not bringing out 7.3, as far as I know. There's no plan and no date for that at all. We'll just carry on using technology levels. And so in 10 years' time, we'll go from 7.2 technology level 18 to 19. And everybody say, well, it's a technology level, I'll do that at the weekend. Don't even tell our user departments that we're doing an upgrade, and it will just go in, and with live kernel update, we don't actually have to have an outage at all to get most of these things done. So that is the way we want to go, and there's no pressure. In fact, it's positive encouragement to stay with 7.2 forever, as far as I'm concerned. This is a little reminder in here. Can you see my little pointer arrow there, Joe? Joe.
Yeah.
You can, okay.
Yeah, I can see your little pointer arrow, sure.
Okay. Well, there you can see. Oh, it disappears if I move it.
Yeah, it disappears then.
Okay. I'll jiggle it around a little bit. You can see 5.3. That's gone, right? It didn't understand any of these ninja technologies at all. 6.1 understands Power 7, but doesn't really move on from there. And so it's going to ignore any technology with Power 8 and Power 9. So this is why we're encouraging people to move forward down this slope. So it's just a little reminder, there are good things when you upgrade to the later versions of AIX. This is the live partition mobility, and again, when these sort of big things come out, it's a big sort of wow factor but they keep plugging away, improving the performance of these sorts of things. So we can see down in here that if you're just moving a single logical partition between two machines, it goes from nearly 70 to 30 seconds migration time. So that's quite a lot lower if you get to Power 9. And you have to have the firmware, you can see that up the top to get the benefit. And if you're moving lots of concurrent LPARs at the same time, and I guess you could think of that as like an evacuation of entire machine because there's a meltdown in the computer room, or the water levels are rising and you try to move it to all the workloads to the other computer room, then you can see big jumps, 700 to well under 200. The time it takes yet to move these things if you're doing Power 9 to Power 9. So there's a little side effect. This takes a lot of work over a lot of time to improve these rates, so we can actually move things around much faster. This is for a 10 gigabyte partition. The little arrow here says, I didn't notice this for the past 2 years. It says end stress. That's my tool. They're using my tools to stress the machine and keep them busier. And you can see it takes a bit longer to move. That's because if you keep changing memory, then it has to send the memory a couple of times before it gets to the 99% moved, and then it can cut over the logical partition onto the new machine and bring the last few pages over as on a demand basis. Okay. This is just a reminder in here for the AX7x2 TL3. So this is a year old now. Some of the good stuff. Hopefully you know this and you'll be using a lot of this in the past year. We'll come to the toolbox updates at the bottom here again in a second. And this is the live, we used to call it live kernel update, but it's just called live updates now of the operating system. And this is the sort of history going forward with the new things going on in here as we do these operations. The new bit up in here, Lara's given me a clue. This is Oracle certified. So if you're running Oracle on AIX, you're not going to go, not do something that Oracle will be horrified with if you're doing live kernel updates. They've tested that out and they're happy for you to do that. So here's the TL4 enhancements in the kernel update, or the AX update. And we're nailing down some little things that obviously some customers are using, not everybody, and they're causing little problems. So we're going around checking these and making sure that they're going to work and put them as officially approved now. So it's Kerberos, the auto mounter, Veritas. I thought Veritas wasn't around anymore, but there it is. A lot of people out there still using it, I guess, and so that's fine. That's supported as well, tested and supported. And usability, I thought was quite nice. The preview checking, they'd rather it fail in the preview and tell you why than you actually fail when you're actually trying to do it, and then it will have to fall back to the original machine to get you out of that situation. So it's best to do it upfront checking for things that we've spotted that could go wrong. Okay. This is the list of enhancements that Petra shows on the screen on technical universities and visiting customers. They're all out of this URL at the bottom, so that's going to be live if you download the presentation. You click there. It's a bit of an eye test on the next chart, and here it is. Can you actually see that? I'm looking at it on a 27-inch screen. It's not too bad. So it's worth looking at that. We've got the gzip accelerator on Power 9 is being better supported now. We'll look at Xive later on. Like an update, we've talked about that. There's some I/O features in here. Down near the bottom, performance improvements for the 100 gigabit network adapters. Some people are moving into those now, and they have lots of very scary advanced features. So we have to make sure they're working fine. And fiber channel device driver. It has better timeout detection and recovery, for example. So these are not whiz-bang demoable things. These are all little things that we've done in the background that will save you getting into problems and let you work the machine, sweat your resources. Now, I'm not an AIX, or I'm not an iSCSI person. I've met some of them. I met some guys in Norway, and they said, tell us about iSCSI. And I said, I don't know anything. And they would ask me 10 questions. I thought they were talking in Norwegian at one point. I have no idea what you're talking about. I had to go and find an expert in it. But that's there and strong. That we got iSCSI port in the VIO server now as well. So you can use your VIO SCSI protocols to get your disks onto the VIO server, and it presents them as virtual SCSI devices to your clients. A nice way of operating if you're big into the iSCSI. Also down in here, I was talking to Petra. SMB version 2.1 has been a long time coming. Well, that's there now. And they're looking at 3.1, but there's some technical issue or a legal problem or something that they're struggling with. They're going to continue pursuing that. Hopefully, we'll see that in a year's time. Now, this is the bit of the enhancements for TL4 that have gone into the toolbox, the AX toolbox. So these are all open source projects that we're doing a lot better these days in having them available in the toolbox. It keeps growing. There's a couple of hundred in here now. So the top half are recent updates that you can download. Oh, the top half is the new bits, and the bottom half are things that have been updated. They're already in the toolbox. So look, scary. They look. Kubernetes on AIX is there. Well, if you're a Kubernetes expert, you can have a look at that. I like Ganglia is in here as well. I've been using that for like 20 years or something now, a long time ago. Down in the bottom list, we got Golang. That's the Google language that a lot of new applications are written in. I've been playing with InfluxDB and Grafana. I think they're both written in Go, or Golang. The GCC is the GNU compiler collection. There's a compiler for Go as well, so you can take that down to binary code if you want to run it that way. Postgres is sitting in here. Python 3, I play with that quite a lot myself. Ruby on Rails, haven't tried that, but that's there. Samba's out here as well, and we're up to date on Yum as well. So these are all like free stuff that you can pull down, and you know that some of the IBMers have done the actual compiling and releasing, so that you know it's not going to have any ghastly security issues that we've added, and you have some sort of credibility that we've gone through some testing with these pieces of software as well. You're not on your own. Now, a couple of these things I've got much more to cover. You know, there's half a dozen slides on these things. This is something quite scary, to be honest. It's persistent memory. So we all know that if you shut down your operating system when you start it back up, all of the memory is zapped with zeros. There's actually hardware to do that automatically. We can't give you the memory with the old content in it, because that'd be an awful security risk. So in here, we're going to actually switch that feature off. So the contents of memory, even if you shut down your logical partition or reboot, in this case SAP, HANA, then when it comes back up, the contents of a big chunk of memory are going to stay exactly as it was. And so the application can look into that memory, find out what state it was in before it was shut down, and continue running. And you might think that's rather an odd thing to do, but when you've got in-memory databases like SAP HANA, and they're multi-terabyte databases, they do take quite a long time to start. But if you already got the data in memory, they can just connect to it and bring up the service a lot quicker. Now, I'm no particular expert in this, but in-memory databases always go faster. I mean, 10 years ago, I was doing benchmarks, and we had, I don't know what it was, a terabyte, perhaps a disk, data on the disks, and then we put a terabyte of memory in the machine, and so we could load the whole thing into the SGA, and you got about a 10 times faster running your database in memory. That was a long time ago, so maybe it's even faster than that these days. So this is the benefit of having it in memory, and you can't buy that any other way, that sort of performance jump. A typical size for SAP HANA is 24 terabytes. That's on the larger side, but that's a lot of memory in a computer. It does cost quite a lot of money as well. That's not a feature of IBM. That's just the cost of these very big DIMMs in the industry. So if you do a cold start and you have to get the data from your multiple terabytes of disk space, loading that and organizing that takes quite a lot of time, like a couple of hours. It could be 5 hours before your database is ready to start doing its work. And of course, those sorts of outages are like horrific for people running big applications on SAP HANA. And so they don't want to ever shut things down. If you never shut things down, that's fine. You just run it forever. But sometimes, you know, maybe it's a new version of SAP HANA. Maybe there's an update in the OS that requires a reboot or restarting a virtual machine. Now, our competition, if you like, is Intel and their Optane sorts of disk memory. It's an actual device. You have to buy new hardware. It's not as fast as memory, but it's a lot faster than disks. So, you know, think of it being like 3 or 4 times slower than memory, but it's a lot faster than disks. So this is going to maintain your in-memory, double quotes, database. In our Power servers, Power 9, we're running the in-memory, actually in memory, and we can do things like shutting down the virtual machine and the OS, or restarting SAP, and not have to do this reload of all the data into the in-memory database. Okay, so you got to think, well, how do they actually do that? Well, you have this large chunk of independent RAM. It has its own life. It has a name and a size, and you've earmarked it for this persistent memory use. And so the machine and the HMC is aware of this thing, and then you'll have this persistent memory attached to a particular logical partition. So when it starts up, its regular memory will be flushed with zeros, and you'll reload the operating system, and it'll take a couple of minutes perhaps. But then this persistent memory is sort of attached to the logical partition, and then it needs to go in there and can it remember what it was doing and where all the data is, and if it can, then it can just bring the database live pretty quickly. So the way they're doing that is big chunk of RAM. It's an independent thing. It's not flushed with zeros when it's attached to a starting LPAR. The memory contains a RAM disk-like organization, so it can be interrogated like a file system, although it is a piece of memory. So you can you can open a file in the persistent memory that describes what the rest of the memory has got in it. So you might say, the first terabyte is your indexes, and the second terabyte was your data, and the third and fourth terabytes are whatever other features you got inside your database. And then it says, okay, so I now know what's in here and where the various things are in memory, and then it accesses it at memory speed like you can do with a memory map file. So it will know that at address 10,000,028,000, this will be the first block of data in the database, for example, and work around all the structures inside the database at that point. And so it actually then runs at memory speed addresses, actually accessing the data. It doesn't have to do read and write operations to get the data from the persistent memory into real memory. It's just immediately there once you've worked out where it should be sitting in your address space inside your process. Okay, so what do you need to get this working? Well, SAP HANA is the version up in here. I'm not sure what that means. You'll be on Power 9 on a Power VM machine, our scale outs or our enterprise machines. Very latest firmware and the very latest HMC. They came out in the past month. Then on the HMC, you can configure your persistent memory and define it for the LPAR so that it understands what's happening. And when we start the LPAR, you'll have the persistent memory there. Of course, to add the persistent memory, the LPAR has to be down. So you have to go down once to get this feature working. At the moment, the operating system is CC/SLES 15.1, and there's a plan for RHEL 8.2. I'm not allowed to tell you when Red Hat 8.2 is going to be available, but let's call it second quarter, shall we? As of my guess. So this is the HMC. This is the actual LPAR 192, and down in here, there's a new entry now in here with the new firmware and the new HMC persistent memory. And you can click on the add in here and you give it a name, the size. This size is tiny because my computer doesn't have 24 terabytes of unused memory in here. You can see you can change it so the size and that you want it to be if you have to reboot it. And then this is the size it currently is. Not even sure what Affinity is. I copied the manual page that if you click on the learn more, this is what you get out in here, and you can read that yourself. So it's fairly easy to configure. The rest of the magic, if you like, is done by SAP HANA understanding what to do at that point if it comes up and it finds persistent memory, and it will try and work out what's in it and save you a lot of time. So your 4 or 5 hours reloading the database now comes down into literally a handful of minutes, or 2 handfuls of minutes, to actually get your service back up and running. Massive saving in outages for these massive great systems with SAP.
So can you still LPM a partition like that?
I knew somebody got to ask me that one. I think so, but of course, to do a live partition mobility with 24 terabytes of data, you're going to have the fastest network on the planet to get that to work in a reasonable amount of time. You could be into like an 8-hour trying to move that over. Because of the volume of memory, if you're making lots of updates to it, it will actually take a long time to move it over and get sufficient percentage over before it can cut over. If you have a very quiet part of the week, maybe you can try and get it slotted in there. Have to check that SAP have certified it that you're allowed to do that. That's a sort of gating factor for the. Now I have down the bottom, the virtual persistent memory. They call it virtual PMEM, which sounds painful to me, like it's a disease. But anyway, and with SAP HANA on Power, system is 6-page white paper, but I couldn't find it on the internet. So I got a couple of links to some overview information. And I'm quite sure if you're an SAP HANA person, you know far more than I do. You know where to get these presentations from. I'm not sure if I'm allowed to change the 6-page that I've got down here. It goes into the right level of detail for me, at least. Okay, now we've already mentioned this one, haven't we? Just checking my time. Right, okay. So this is Xive, the external interrupt virtualization engine. Xive. Great. Sounds great. I wonder what it does. Well, to try to understand this, you have to know something about how Unix/Linux actually does interrupts to start with. So I thought I'd backtrack a little bit and would explain that on the next chart. I think actually these are my notes. I've left them in here. Okay, so I'll cover the prereqs Power 9 and firmware 940. Yes, this is a good point. When I talk to the developers of AIX, and I'm talking about the deep techies in here, they practically say, well, it's internal and the customers won't even know, so we're not going to tell you that we're doing this sort of stuff at all. And I was ready to give a presentation at a technical university, but it actually turns out very hard to do that. I've got a white paper, and I'm an ex-kernel programmer. Right? I did 10 years programming inside the real Unix kernel. And I got lost on page 3 out of 10 in their white paper. So we'll come back to that in a minute. I'll try and explain. Here's my diagrams rather than all those words. Okay. So this is, go back 30 years where things were a lot simpler. You had a Unix kernel running your machine, all right? And you have user programs up in here. And there's 2 ways of getting into the kernel. The first one is the user program makes a function call. It happens to be a system call. And that will actually jump you from the user mode. He's in a nice little sort of constrained bucket of his address space. He can't do anything. He can't see any actual hardware, well, apart from the processor because it's running the instructions. He just sees this piece of memory. If you actually want to do anything real world, you have to make a system call and get the kernel to actually talk to a device driver that will talk to an adapter that talks to a network or whatever it is. So these are context switches, and the sorts of things you have to do while doing this is when you jump from user program to the kernel mode, you have to say the program counter. That's pointing at the next instruction that the program wants to run. You have a stack pointer where your heap is. You have 32 registers, which are either integers or pointers. This is the scratch pad, if you like, that the processor's using to do the work. With lots of condition bits whenever you run an instruction. There's sort of bits that are set if it underflows or overflows, or was it 0, and all sorts of other conditions in there that you might want to do a branch operation on. The floating point registers have to be all saved as well, and the virtual memory context has to be changed because the virtual memory in the kernel is different to the virtual memory in the user program because the kernel can talk to every single piece of memory and the adapters. So all that has to be sort of swapped out, and the kernel equivalent of this swapped in, and then it can make the kernel can actually do what it wants and return some data perhaps back to the user program. Typically these are open and close of everything's a file in Unix, isn't it? So there's files or sockets or whatever you want to do, networks, and then you're doing read and write operations. Sometimes it's get out info. So the smallest possible system call is get the PID of myself, and the kernel just returns you your process ID. Right, there's another way of getting into the kernel. This is like the top end, the system calls. The bottom end of getting into the kernel is down in here. Something grubby happens with a packet arrives in an adapter, and the adapter says, okay, I've got the entire packet. I better tell the operating system what's going on. And it raises, literally, it goes from 0 to 1 volts, a line going into the computer. There's a hardware interrupt controller, it's a chip in here, says, whoa, adapter 23 needs some attention, and it actually goes into the processor and forces the context switch, whatever the processor is actually doing. It's usually user programs, isn't it? You should be running your user programs 80% of the time, and the kernel 10 to 20% or something. It'll do a context switch into the kernel, Then it will actually call the device driver to handle what the adapter wants. Now, device drivers come in two halves. There's the top half and the bottom half. The bottom half actually talks to the adapters, the registers and the adapters, queuing up, disk I/O that you wanted to do, and then you let the adapter work out which order it wants to do that, and just lets you know when it's finished, either pumping the data out or it's got a block full of data that's come in that it wants to hand over to the kernel. The top half of the device driver is actually dealing with the user program. So if the user program is trying to send here's 8 kilobytes I want to send down the network, then the top half of the device driver gets it from the user program into the device driver, and then calls the bottom half, tell the device driver, here's the block of data, push it out onto the network. So you've got the two halves. So you have to dive into the bottom half of the device driver and handle the interrupt. Maybe it just wants an acknowledgement that, yes, we understood that's finished. Or maybe it's asking if you, what's the next thing you want me to do? And you have to go and get something off a queue and tell it what you want to do next. So that will actually come back into the kernel, and then it'll do a context switch back to the user program. Okay, that was the 101. Very easy way of doing things. Right, now, then we've done some other things in our machines. We've got virtual machines, haven't we? So we got lots of kernels running on here, all of them running device drivers, all of them having different sets of user programs. And now in a modern machine, anything from Power 3 or something like that, we have these sort of features. When the interrupt comes in, it goes into the hardware controller, and not only does it have to interrupt the kernel, it has to say, well, I don't even know which kernel I should be interrupting. So it has to cause an interrupt on one of the physical processors, and it's not quite sure what it's doing, but maybe it's running this LPAR1. So we do a context switch into the hypervisor, which is like a super duper kernel, understands all the kernels that it's actually controlling. And then it says, okay, that interrupt should have gone to virtual machine 3 over here. It's nothing to do with you. Sorry I interrupted you. Back you go. Another context switch back. And then it actually passes the interrupt into the right kernel, and then he goes around the loop, contexting switch out, deals with it, context switch back to the user program, and carries on. So we've got two levels of interrupts going on here. Now, if we actually go backwards, So, yeah, try again. Didn't recognize it. Okay, so in the good old days, when I was a lad, just 30 years old or something, if we were running 1,000 interrupts a second, we were motoring. Our database was flying along. When you get into the modern computers, we're getting tens of millions of interrupts a second for all the adapters and all the logical partitions in here. And that is actually taking a significant amount of processing, just handling those interrupts, the context switches, and running the device driver to handle the interrupts. So this is what this Zive is here to try and reduce the amount of double context switching, at least in here. So this is a diagram that we've seen at many of the technical universities over the past couple of years. IBM, I think, has postponed implementing the Zive because they want to do so much testing of it. Because if this thing goes wrong, your whole computer is going to grind to a halt in like 4 microseconds or something. So it does have to be done right. So the big difference in here is we have this thing called a Zive, which is the hardware bit of the interrupt handler. It has the hypervisor is managing a routing table in here. So the hardware can actually work out which LPAR and which virtual processor in an LPAR it should be sending this interrupt to. So it doesn't have to invoke the hypervisor to work that out. It's like doing it in advance, and it's got a table to let the hardware actually look at that piece of memory and work out what to do. So we have to work out the right LPAR, and then usually the virtual machine that requested the interrupt after the action is taken, you hand the interrupt back to the same virtual processor because he has the device driver and any memory associated with it actually in his cache. So it's good to go back to the same virtual processor. That's the easy scenario. There's all sorts of things that go horribly wrong. For example, one virtual processor could be in multiple LPARs, couldn't it? The first VP in here could be actually running LPAR 2 half the time and LPAR 3 half the time. So we've got to be very careful that we actually get the right virtual processor in the right LPAR. We know that AIX, for example, can fold away virtual processors if it doesn't think it needs it. It hasn't got enough work to keep that virtual processor busy. You can tell the hypervisor, don't schedule this virtual processor until I tell you I need it again, and then the virtual processor can go and help out more in other LPARs and do some work for them. So if it's folded away, we'll try and send it to a virtual processor that it's folded away. It won't action the right virtual processor. So it has this concept that I think is being represented here by this line down here. This is a group of virtual processors. So if the one you were after is asleep, you can look at, okay, he's got to ease in a group of friends. Maybe one of the other group in his group, another VP in his group can actually do the interrupt for him. Of course, we can then be doing dynamic VP changes. So when we started the action to the adapter, the VP might have been in one LPAR and it got moved, or that VP was the LPAR was reduced in size and the VP doesn't exist. So again, we have to have that sorts of things. And then we got DPO, which is actually going to shuffle all the LPARs and the virtual processors around the machine to make them better for CPU memory efficiency. So it will lock it while it's doing those sorts of things, but then the Xive has to work out, okay, all bets are off because we've shuffled everything around. In that case, it's sort of fallback position. It will go back to the old mechanism. We'll actually invoke the hypervisor, and then actually have to work out what it was because it can see everything in here, not just the routing table that's been invalidated. So this is what it's doing inside all of this. So here's the requirements. The 940 firmware only came out 4 or 5 weeks ago, so it's brand new. So I quizzed the developers and said, okay, how do I install that? He says, well, it's just part of the TL4, so nothing to store. There's no packages as such. You're not aware of your interrupt engine software and you install AIX, so it's invisible. Activation, there's nothing. If you meet the prereqs, it will switch this on, and if you're missing a prereq, then you just use the old mechanism. Monitoring, there's no way of monitoring it. You can't say it's doing better or worse. If you do a benchmark before and after you get to firmware 940, you may be able to spot the difference in performance, and there's no user commands to switch it off or on, or to monitor it or tune it. There's just nothing for you to do, right? But then you say, well, okay, what's the benefits? Well, they say, well, we did test this quite a long time, and I'm not allowed to tell you the number, but if you I'm waving my hands in the air here. If you think of your CPUs on a busy logical partition, that 80% of your time you should be running your user code, your applications, your programs, and then maybe 10 to 20% of the time you'll be running in the kernel mode. The kernel, of course, is half of it's the top half, dealing with system calls, and half of it's the bottom half. So half of your system time is interrupt handling, and we're stopping this double use of the interrupts in here. So you take the 10 to 20% and you halve it, you get the bottom half, and you halve it again, that's the interrupt handling that we're trying to save. So that may give you an impression of how much faster you will actually go. But let's face it, you just upgrade and it's free, going faster. Of course, the more interrupt handling you are doing, the bigger the benefit will be. If you've got an application that you give it a query and it sits there for 4 hours and comes out with the answer 42, it's doing no interrupts at all. It won't make any difference at all. But if you've got very fast networks, 100 megabit networks, or lots of fiber channel going on with lots of vast bulk of data coming in and out of the machine, actually Ethernet's probably worse because your fiber channel will be dealing with big blocks of data coming in, where your adapters your Ethernet adapters may be dealing with lots of tiny little packets, high transaction rate, high numbers of interrupts, then that's when again it's going to make the biggest difference on your computer. It's a free upgrade. Now this is like pretty advanced technology, and I'm not sure if anybody else in the industry could actually be doing this. IBM controls the Power 9 chips. It's controlling the hardware sitting on the motherboard that's dealing with this. And so it's controlling the firmware and the operating systems. You have to do it all and keep them all updated and in sync to actually implement this feature, which is very hard for like the Intel guys because they got different people, different motherboards, different firmware, all sorts of things going on here that make it very difficult to pull all this together. But as our machines get bigger and bigger, this is going to be quite a large percentage benefit as we get bigger and bigger and faster and more interrupts in our machines at any one time. Okay, now there's this white paper that I got a copy of it, and to be honest, I can't remember where I got it from. It's actually in the IBM Journal of Research and Development, because this development is like leading edge technology that all the guys like to report these official functions and conferences about the very latest features in here. These two people in here have 120 patents between them. One of them has been with IBM 47 years. And where you get this information is actually on the IEEE. I'm not sure if to be a member or you just have to register. But here's the document that you're looking for and the title. So once you're in, you should be able to find that. 10 pages. As I say, I got totally lost on page 3. Making lots of assumptions that you've been doing interrupt handling for a decade and you understand all the principles and the problems that they're dealing with. But the first 3 pages were very good reading. Oh, this is the abstract. You can actually see this online if you go and have a look. I'll spare you the details. All right, now, I never said this, right? No, your mind went funny and you imagined this. So we're not finished with the Power 9 server range yet, and it's not announced, so I can't really say much, but I do have one. Well, me and Gareth Coates have one in a rack in London. It arrived last week, and our summary is very nice computer. There are a few things on it we're thinking, what on earth, what are these nail heads doing halfway down the lid, for example? And then you suddenly work it, when you put it on and push that forward to lock it in, that actually grabs hold of things underneath the covers and makes the box nice and rigid. There's really bit of clever engineering in here. There's a choice of 3 different CPU cores. That's a size, and the gigahertz is about... some odd noises on the line here. It's on the smaller end of the range. It's not a big enterprise machine, and the terabytes is very good. Lots of slots and adapters in the machine. I was quite surprised they could jam all them in, to be honest. And it's got sort of 3 purposes in here. The first one, which is where it's primarily aimed at, I think, is it's got GPU adapters in here, so for high performance computing and these AI workloads. This is exactly what it's for in here. It also has 24 disks in the front. Maybe I shouldn't have said that. You can put a lot of terabytes in here. 150 terabytes of disk can go in the front, so that's quite good use of the machine as well. So you may have some that are being used as a storage adapter and some being used for the gigahertz on the GPU adapters, doing all the maths and the calculations. But it could also be used for, if you haven't got the GPUs in it, general Red Hat OpenShift sort of work engine, or a generic Linux machine using KVM to run lots of virtual machines for cloud work. So it's got four good uses in here for this particular design. Can't tell you a date, but it's not this year. Now, I'm not saying anything in here, but maybe you'd like to have a look at this website in here. You can see in here the US Army's bought $12 million worth of a computer. It's a cluster, so it's called a supercomputer, and you can find out some information on that. Now, the reason I'm sharing this with you, if you just happen to have $12 million of spare cash and you want a computer designed exactly for your needs, do get in contact with IBM, because we can, if it's a big deal, we can cut your special machine just for you if you want. And then if you turn out that we think this is generically usable, we'll actually sell the same designed computers with other people. Okay, so YouTube. I've been busy on YouTube. I go to the technical universities and talk there, and I decided all all the talks. Excuse me a second. I'm going to go drink. All the talks I give in technical universities, I convert to YouTube videos, and this was quite a popular session around getting the best performance from your Power 9. And there's a 5-part series, and these are the parts and how I split them out in the end. The first one, there's a best practice document that not many people seem to find. There's something really peculiar about the memory prices, so I'll cover that and keeping up to date. Then we look at using this VP to E ratio, and we've known that for a while now. It's just a reminder that you've got to get that right. And then we look at how much faster the Power 9s were over the Power 8. So then we say, well, how did they do that? And can we make sure that we're going to play to its strength, which is particularly looking at the VP and E ratio. We do a quick detour into the Spectre meltdown, and can we ensure that that is switched on? What's the command to do that? And we make a couple of jokes about single-threadedness. That's been a very bad mode of writing a program for 25 years, and if you've still got one, well, just switch it off is my recommendation. That will focus some mind in the management to actually get the program fixed. We look at the max mode and the variable frequencies that we have in there for those machines. Why is that a range? In Power 8, we told you this is the frequency I run at, and in Power 9, we said, no, it's in this range in here, as we actually work out what that actually means. And we looked in Part 4, how to actually monitor the frequency. And if you are running maximum workload in a very hot computer room on top of a mountain, you might see the gigahertz dip slightly if you go very, very busy. But you may never see that if you don't have the worst of the worst of the worst case. ASHRAE is the actual specification of computer rooms. And then Part 5 is all about utilization and why they're not so useful. There's some serious deficiencies that a lot of people haven't worked out in looking at utilization numbers. So we cover that. So that's an hour's worth in here. Some of the slides I've taken out. Look at beautiful pictures. And so go and watch the videos and I'll explain what all that lot means. Okay. The next one is at a technical university, again in October, I think it was, advanced topics for NMON, and that's a 4-part series. Part 1 was a reminder of the good old technology and introducing you to NMON chart if you haven't seen that. Yeah, I like this for yeah, never tell a friend, gosh, your baby's really ugly, because you can never recover from that. But I quite often get email that starts off, NMON's rubbish, it crashed, and the answer is user error 99% of the time. But maybe NMON's not as bad as you think. Here's 15 things that I quite often get questions of because people don't realize that NMON can actually do those things. So I'm not going to go blow by blow through these. You can go and look at the videos to do that. Then we look at what next, and I think most of you might work out what next is NJmon. Did I skip 2? No, I'll try again. If you're new to NMon, there's some people out there that haven't actually used it. It's amazing, isn't it? There's 2 loads of hours, whether you're on Linux or AIX, to get you started. YouTube videos. Right, this is something to look at while I have another little sip of water here. I'm going to be going very fast. We should make it. Okay. Right, so this is NJmon. This is different to nmon because it's saving JSON data that we pump into a time series database. Then we use a graphing engine to produce graphs like we have over here. And although I'm using InfluxDB and Grafana, and I'm using those because they're very simple to install on Linux, on Intel, or Power. It takes about 10 minutes to install both of them, and then you can get the benefits. These beautiful graphs over here. At the bottom of the previous slide, I've also used the JSON data and go into Splunk, and it'll also go into Elastic, which were called Elasticsearch, which some people call ELK. It's the same company. been working with some people that like those tools and making sure the NJmon data can load into those as well. Okay, so there's another set of graphs in here. This is actually a big board that I used at a show and tell while we were there. There's 2 hours of videos that covering NJmon that will tell you practically everything I know about the subject. Well, not quite. I actually captured this just as I launched them, and it says 64 views. I looked last night. There's 5,000 people have looked at these videos, so you know, we're getting some traction in here. So make sure you don't miss out. The reason I'm doing these things is because, you know, things have moved on for the nmon. It's a little bit old-fashioned, so you say, and it ends up with loads and loads of files, which is a major disk data management problem. Pumping this straight into a time series database just eliminates that completely and lets you concentrate on doing these really beautiful looking graphs to get the information you want out of them. And I want to make sure that AIX and Linux on Power don't get left behind with all this good technology, the time series databases and things. Okay, now we actually gave a virtual user group here with Joe in February this year when we were just starting out with nmon. It was working, but a lot of things have happened since. IBM actually allowed me. I fell off my chair. I thought, well, let's just ask, and they can only say no. And they said, yes, okay. So I went to an InfluxDB conference, a 2-day conference. And in the first hour, they went through like 101, this is the basics. And they suddenly realized, I'm doing that wrong. So I wasn't using tags. And that allows you to group by operations for any resource that you have varying numbers for. So you have varying numbers of CPUs, variable number of disks, you know, per LPAR, or virtual machine network file systems and processors. You can use a tag, group on that tag, and then it will just draw the graphs and name all the all the network names will appear on the graph automatically. You don't have to hand crank any of that. nmon chart, so we can actually, if you only got one NJmon file, it'll actually generate you a web page for the graphs, a bit like nmon chart. This is actually up to, I think, 9 now pre-made dashboards on the Grafana website. You can download pre-made set of graphs for AIX and Linux and all sorts of things in here. We now collect shared processor pools. Typically, people use that for license management. So you have to go to one of the virtual machines that's in the pool. For example, Oracle, that's the license, the number of licenses you hold, are all those CPUs in the pool. If you use one virtual machine that's actually in the pool and you switched on the stats to let it access what's going on in the pool, then you can actually see how much of your shared processor pool is being used, as well as how much this virtual machine is using. We added GPFS stats. That was people have been, I was a little bit concerned about the lack of stats coming out of that, so we can do that, AIX and Linux. The AIO server, Oracle tends to use that, that's in there. We fixed time creep. You tell NJmon to capture maybe every minute, for example, but it actually takes a finite time for it to run. So every time we run it, it starts slightly later in the minute until there's a minute without any stats, and then the time creeps over. So we fixed that so that it's on time every time now. We have process stats going in here. The threshold's a bit low, so we're picking up too much data. We don't want to know something that's running 0.001 of a percentage of the CPU time. We've got shared storage pool, virtual disks and stats in here. We've made these changes for Elastic. They actually wanted arrays instead of dictionaries in one part of the data, so we fixed that. NFS is in there. We collect data on the GPUs, so we can get the gigahertz rating on the GPUs, the amount of electricity taken, and how much the temperature on those CPUs as well, and how much memory it's using on the GPUs. This is a very recent one. Oracle, if you're using ASM disks, they're sort of raw disks, but the disk sizes go missing. So we found a command that can get that, and so we can actually get the sizes of the ASM disks that aren't usually available. We've improved the process naming, so we have the name of the command as well as the PID in here, and so this name of the command actually appears on the graph, so we do a group by operation. We've moved to line feed separated JSON records. As the Elastic guys pointed out that my JSON files weren't actually using one of the 4 standards for multiple records. That was embarrassing, but we went off and fixed that. Over here in yellow, we've got I've got a guy that's running 1,000 endpoints and he wants to get to 10,000 endpoints. He starts up NJmon at midnight every day, but he's using network time protocol, so they're all starting in exactly the same second. And so they all try and send the data exactly 1 minute later. And so his influx database engine machine gets to a run queue of 700 on that second. In 3 seconds, it actually drains out all the stuff, and then it spends 98 seconds doing nothing. And then wham, there's another load of data arrives. So we get randomized little sleeps as they start up, so that we spread out across the minutes. I'm working on a project to merge the collector and injector into a single Python program, going multi-threaded. It should be more efficient. And we're trying so that if the collector fails, or you want to restart the collector, all the NJmons will say, okay, I failed to send the data, I'll just try the next time. And I'll keep going a number of times and then pick up the new collector when it starts up. Yeah, we're going to try testing out to 10,000 endpoints, which is quite a hard work, to be honest. Okay, so that's it. That's the time done. 2 minutes over. That's pretty standard for me. Any questions out there? I'm not tracking the questions.
Oh, well, let's see here. One was NJmon can be installed on P7 AIX LPARs.
P7.
Power 7 AIX.
Yeah,
NJmon's work on.
You don't write to a power hardware. You write to a copy of AIX,
right.
and it's hiding the hardware from you. So we can run on AIX 6.1, 7.1, 7.2, no problems at all, and VO Server 2 and VO Server 3 for measuring those ones as well. So that's easy. Yeah, next one.
All right, so a couple on this XIV stuff. One is there any VIOS release that's a prereq for that?
No, the VO servers won't be using this.
Okay, and do you foresee Linux variants adopting XIVE for their PPC64 variants?
Well, yeah. So you had a session from Ron Gordon, didn't you? Last time, was it, or the one before?
Yep. A couple times.
He was showing that the IBM for the power hardware provides a whole pack of extra stuff to make it more reliable and faster and all that sort of stuff. So there is that chunk in there that IBM provides, and it could be included in that, given enough time and resources and enough interest that the Red Hat, SUSEs and Ubuntu's want to pick up those packages. I don't have any dates or times or likelihood of that happening, but it is a possibility. Talk to your vendor if you're very keen on that.
Another question here about any ideas if this will change, if this change will increase the amount of memory that the hypervisor claims, and I think that's also with regard to XIV.
Yes, by maybe 4K kilobytes of extra memory. It's tiny. Yes, it's a lookup table that it's going to have in there, but it'll be a couple of K. I don't think it's going to be big at all.
Okay, I'm kind of scrolling back here, Nigel. With I answered some, but there's some I didn't. And one was on the persistent memory. If you actually power, so 2 questions. One is if you actually power the system off. I mean, not just the LPAR down, but if you power that system totally off and bring it back up, do you still have that persistent memory?
Yes, that is the one that we can't deal with. Yes, so at that point, if you restart the box completely, then yes, you're going to lose the contents of the memory. In the report I saw, it said that would happen if you need to do a hardware upgrade. But then we were saying, hang about, if you've got dark CPUs and dark memory, you put the activation code on, that's a hardware upgrade, and that would let the LPARs carry on running. So that we could knock that sideways for at least most of the upgrades on the bigger machines, where these, if you want 24 terabytes of memory, you're going to be on a big enterprise box anyway. But if you want to scale that machine, then we can't switch on the extra CPUs live. But that is a gotcha. Yeah, that has got a gotcha.
Okay, and one more is on the persistent memory. Somebody asked, and actually answered this one. I wasn't positive, but they asked if that persistent memory could be shared across the LPARs, like another one have it as read only.
No, not at all.
Yeah. And I said no. Okay.
Well, yeah, we're at version 1. When we get to version 28, who knows? We could do any sort of thing. But I can see where you're going, where you want a read-only copy of the current database for reporting purposes or something. But and I think IBM would prefer you to buy another 24 terabytes of memory. I think are the answer to that one.
All right. So I know we are out of time here. You did have like a couple more slides you wanted to talk about. Do you want to do those, or?
Yeah, let's do those. We're going to switch to recording.
I am stopping the recording here.
Okay.